Hi everyone, welcome to week 4 of distance learning. This week we're going to be focusing on solving exponential equations. So you're going to have this set of notes that you're going to look at, and you're going to have a quizzes assignment that you're going to be doing, and then you're going to have your Google form reflection questions. But watch this video first, take some notes, get acclimated with the material, and then you can try the other stuff. I'm only going to do some of the problems on here. The ones that I don't do are for you to practice. There is a key on Google Classroom for the entire page, so you can go there to check your work. But I do want you to, after I do one, I'm going to ask you to pause the video and try it. And then I want you to go to the key on Google Classroom and check that you did it correctly. Okay, so the first thing we're going to be looking at is solving exponential equations. The trick here, there's two different cases. The easy case is if we have like bases, meaning that the big number that is attached to the exponent is the same on both sides of the equal sign. So, for example, on number 1, the base there is 2 because the number that's attached to the exponent is a 2. And because of this, you can basically just cross them out. So I can get rid of this 2 and I can get rid of this 2. And what I'm left with is the exponents, and I'm going to set those equal to each other. So I'm going to have 3x is equal to 15, and then I'm just going to solve that like a regular one-step equation, divide both sides by 3, and we get x is equal to 5, and that's my answer. Okay, let's look at you guys can do number 2, so at this point, if you want to go ahead and pause the video and try number 2, go ahead and do that. Let's look at number 4, just because it looks different. The bases are the same, they're both 8, so I'm going to cross those out. And I'm going to be left with x minus 3 equals 5. I'm going to add 3 to both sides to get x by itself. So you get x is equal to 8. Let's try a more difficult one. I think y'all can do those. Let's look at number 6. So the base here is 5. I can cross that out on both sides. And I'm going to be left with 3x is equal to 6x. Your goal here is going to be to get all the x's on one side. So you can either subtract 3x from both sides, or you can subtract 6x from both sides. I like to keep my numbers positive, so I think that subtracting 3x on both sides would probably be easier. So I'm going to do that. So over here, these are going to be gone, and they're going to turn into 0. And then 6x minus 3x is 3x. 6 minus 3 is 3, and then tack an x on the end of it, okay? And then in order for me to actually solve for x here, I'm going to divide both sides by 3 to get rid of the 3 in front of the x. 0 divided by 3 is 0. So your answer here is going to be x equals 0. Okay, let's look at number 7. So I'm going to cross out the 9's that are here. I'm going to have x equals 6x plus 10. Same thing, I want to get all the x's on one side and all the numbers on the other side. In this case, since I want to organize all the x's on one side, I'm going to move the 6x to the other side. I know that it's going to make it negative, but it's going to be easier than moving an x and then moving it back, okay? So x minus 6x. So think about it like this. You've got $1 and you spend $6. You're in debt now, but you're in debt $5. This is negative 5x equals 10. Then I want to get rid of the negative 5 in front of the x. So you're going to divide both sides by negative 5. So you get x equals negative 2. And that's your answer. Let's look at number 8. So on number 8, we're going to have to use some of those exponent properties we looked at last week. You are going to multiply the 3x and the 2 together. So this is going to be 7 raised to the 3x times 2 equals 7 to the 6th. 3x times 2 is 6x. Okay, now we've got a single exponent. I can cross out the 7's and set the exponents equal. To solve for x, I'm going to divide both sides by 6. So you're going to get x is equal to 6 divided by 6 gives us 1. So that section only works whenever your bases are the same. This is kind of the easier case, okay? Let's look at the next page. So this is the more difficult case when the bases are different. So the example problem that's up here, I'm highlighting it in red, they don't have the same base. So what they're gonna do is find another way to rewrite it with the same base. Whenever you're comparing the bases, so the bases in this case, in this problem, are 2 and 4. Your common base is always going to be the smaller number. So I'm not going to rewrite 4. I'm going to rewrite 2 in terms of making it look like the number 4, okay? You can also do this on your calculator. So I did a little screen record just to show you how to do it on your own computer. If you downloaded the TI Inspire app, this is what your screen would look like in the app. So I went to the little wrench looking symbol that has the tools on it, and then I'm going to go to where it says factor. And then if I wanted to factor, say, 4, that would be 2 to the second power. If I wanted to factor, let's say, 27, that would be 3 to the third power. If I wanted to factor 64, that would be 2 to the sixth power. Let's do some examples. So I just showed you on the calculator how you would find the common base between 2 and 4. So the two bases here are 2 and 4. I need to rewrite 4 as base 2 raised to some power. Well, 2 squared gives me 4. So what I'm going to do is on the side that says 2 raised to the 3x, it already has the base of 2 that I want. So I'm just going to leave it as 2 raised to the 3x. On the next one, I'm going to replace 4 with 2 squared, and then I'm going to raise that to the 9th power. So all I've done in this step is replace the number 4 with 2 to the 2nd power. Okay. Now I can take my laws of exponents and I can multiply the 2 that's inside the parentheses with the 9 that's outside. So this is going to be 2 to the 3x is equal to 2 times 9 is 18. Now the bases are the same. They're both 2. So from our previous section, I can cancel those out and set the exponents equal. So you're going to have 3x is equal to 18. Divide both sides of that by 3. And you're going to get x is equal to 6. And that's your answer. Okay, let's try number 2. So in this case, the two bases are 3 and 9. The smaller of those two numbers is 3. So that means I need to have a base of 3 on both sides. The left-hand side already has a base of 3, so I'm just going to bring that down. I need to figure out how am I going to rewrite the number 9 as base 3 raised to some exponent. Well, 9 is equal to 3 squared. So I'm going to rewrite the 9 that's here as 3 squared. And then I'm going to raise that to the 10th power. So all I've done is change the 9 that's here into 3 squared. And you can use that calculator trick that I showed you if you download the app, or I'm sure you can access it on the computer as well. Download that app and you can do the same thing that you did on the calculator. So here, this is going to be 3 raised to the 2x equals, I'm going to multiply the 2 that's on the inside and the 10 that's on the outside. So this is going to be 3 raised to the 2x is equal to 3 raised to the 20. Now that my bases are the same, I can get rid of them. And this is going to become 2x is equal to 20. To solve that, you're going to divide both sides by 2. And you're going to get x is equal to 10. Let's take a look at number 4. So my two bases here are 2 and 8. The smaller of those two numbers is 2. So I need to rewrite the number 8 as 2 raised to some exponent. Well, 8 is 2 to the third power. That means that 8 is equal to 2 times 2 times 2. Okay, so my base on the left-hand side is already 2. I'm just going to leave that as is. I'm going to rewrite the number 8 as 2 to the third power, and then I'm going to leave the 5 on the outside. So I'm going to have 2 raised to the x minus 3 equals 2 to the 3 times 5. So that's 2 to the x minus 3 equals 2 to the 15th. Now that the bases are the same, we're going to get rid of them. And this is going to become x minus 3 equals 15. To solve this, you're going to add 3 to both sides. So you're going to get x is equal to 18. Let's look at number 5 now. So my two bases are 10 and 1,000. The smaller number of those two is 10, so I know that I need the base of 10. So I need to figure out how to rewrite 1,000 as 10 raised to some power. Well, if I do 10 raised to the third power, that's 10 times 10 times 10, that would give me 1,000. So I need 10 raised to the third power. So on the left-hand side, the base is already 10. I'm not going to change anything there. On the right-hand side, I'm going to rewrite 1,000 as 10 to the third power, and then keep that 11 there. So on the right-hand side, I'm going to have 10 to the 3 times 11. 3 times 11 is 33. So now I've got the same base on both sides. It's both 10. So I can get rid of those. And I'm going to rewrite this as 5x plus 3 equals 33. And then we're going to solve for x from there. So I'm going to subtract 3 from both sides. Then I'm going to divide both sides by 5. And we're going to get x equals 6. Okay, let's look at number 7. Number 7 is kind of a unique case. Looking at our bases, we've got 4 and we've got 8. So ideally, I could pick the smaller number and say, okay, the smaller number is 4. And I need to figure out 8 is equal to 4 raised to what power? Well, that blank space, there's nothing that I can put up there. Because if I do 4 to the first power, that's 4. If I do 4 squared, that's 16, which is bigger than 8. So I can't use that rule of just taking the smaller number here since I can't find anything to raise 4 to the power of to get me to 8. So I'm going to have to change both of the bases this time. So let's look back at our calculator. So what I'm going to do here is use the calculator to find out how to make those common bases. So I'm going to go to my Inspire app again. And I want to find the factors of 4 and I want to find the factors of 8 to give me that common base. So what I do is I go to factor and I find the factors of 8. So that gives me 2 to the third power. Then I'm going to go to factor and I'm going to factor 4, which is going to give me 2 to the second power. So essentially what that did, I'll just rewrite that out here. 4 gave us 2 squared. And 8 gave us 2 to the third. Notice that both of those share the base of 2 in common. So the common base this time is going to be 2. So I'm going to rewrite both bases on both sides of the equal sign in terms of 2. So instead of writing 4x, 4 to the x, I'm going to write 2 squared to the x. And instead of writing 8, I'm going to put 2 to the third. And then I'm going to keep that 6x plus 12 in parentheses. Okay, so what I've done in this step is I've replaced the 4 with 2 squared, and I've replaced the 8 with 2 to the third, and the exponents have stayed the same. Now I'm going to multiply and simplify. So this is going to be 2 to the 2 times x. This is going to be 2 to the 3 times 6x plus 12. So on the left-hand side, we're going to end up getting just 2 to the 2x. On the right-hand side, I need to distribute that 3 on the outside to both of the terms inside the parentheses. So 3 times 6x gets me 18x, and 3 times 12, 36. Okay, So now my bases are the same. They're both 2, so I can cross them out and set the exponents equal. So I'm going to have 2x equals 18x plus 36. I want to get all the x's on one side, and I want to try to keep the 36 by itself. So I'm going to subtract 18x from both sides. So 2x minus 18x, think of it like you have $2 in the bank and then you spend 18. You are in debt this time by $16, so that's negative 16x equals 36. In order to get the x by itself, I'm going to divide both sides by negative 16. That is not going to reduce to a whole number, but we're going to reduce the fraction as much as possible. So we've got negative 36 over 16. Remember, if the negative sign's on the bottom of the fraction or if it's on the outside of it, it doesn't matter, it means the same thing. So let's think about what can I take out of both of those. So what can I take out of 36 and 16? 4 will go into both of those numbers. So if I do negative 36 divided by 4, I'm going to get negative 9. And if I do 16 divided by 4, I'm going to get 4. So I can't reduce that fraction any further because there's no more common factors between 9 and 4. So x equals negative 9 over 4 would be my answer. The next video is going to cover the rest of the notes, the solving rational part. But at this point, I want you to just go ahead and pause. And the questions that I did not do on the video, I want you to try to do them and then check on the key on Google Classroom.